So we were talking about the PDF. PDF is probability density function, and it has been defined as fx, where it starts from one extreme A and it goes up to B. So we integrate this function. So this is probability distribution function, and from A to B, if it is fx dx. This is probability distribution. There are two conditions. If it fulfills the two condition, then it will be called PDF. First is this function has the value greater than equal to 1, 0. Second, that if I integrate it, it reduces 1. What does it mean? If let us suppose we like to find out the probability of getting the school students of class 10th to have height 5.9 as or 5.5 as we were discussing it earlier. So what I have to find? I have to find 5.5 as we were taking in the last example. Now, x is a continuous random variable. Now it can be solved as, if I suppose 5.5, it lies between which two values? It lies between 5 to 6. So my all observations are in between 5 to, and if my all observations are between 5 to 6, such that the sum of all these observations, sum of all observations, where my observations, all my observations are lying between these two extremes is equal to 1. One thing, this concept will be applied. Now, as we were talking about this diagrammatic representation, this all observations lies under where this is my average, mean, median, mode is equal to 0. It's a normal distribution case, right? Normal distribution numericals generally to this level which we are dealing it remain concentrated towards the concept that what is the probability that the observations lies between particular value for a particular value. So if I say average is here, 100% is lies in under this curve. So 1 standard deviation, 2 standard deviation, 3 standard deviation. This is if I move plus minus 1 standard deviation, that is plus minus standard deviation is represented by sigma, plus minus 1 sigma. Here plus minus 2 standard deviation, it can be represented like this. It is represented by like this. So in this case here, this first line represent plus 1 standard deviation. This stands for plus 1 standard. Here it is plus 2 minus 2. Here it is plus 3. Now, what I have to make you understand is between this range, that is average, mean, plus minus standard deviation. In this case, if I write like this probability of the observations between minus standard deviation 1 plus 1 standard deviation. Plus minus 1 standard deviation, this gives you the percentage of observation which lies between these two range. जो टोटल ऑब्जर्वेशंस हैं वो आपके कितने हैं 1 मीन्स 100%. 100% इस ऑब्जर्वेशन इस पर्टिकुलर पूरे ग्राफ में नॉर्मल कर्व में कवर हो जाते हैं. तो अब इस केस में है 68.2%. किसके बीच में? प्लस माइनस 1 स्टैंडर्ड डेविएशन में आता है 68.2%. 100% में से इतना परसेंटेज इस पर्टिकुलर रेंज के बीच में ऑब्जर्वेशंस विल बी फाइंड इन द केस ऑफ नॉर्मल डिस्ट्रीब्यूशन इफ द पॉपुलेशन इज नॉर्मली डिस्ट्रीब्यूटेड. नेक्स्ट इट कम्स 95.4% of the total observations will lie for plus minus 2 standard deviation. इस केस में अगर हम उसको ऐसे रिप्रेजेंट करते हैं, ये तो हो गया आपका 1, ये वाला केस. अब यहां से ये 2 standard deviation, minus 2 standard deviation from the central value that is average and plus 2 standard deviation from the central value mean. इसके बीच में ये total number of observations हैं. Here in the normal distribution curve it is 95.4%. So here I can say it is 95.4%. And the last, majority of the observations, that is somewhere 99.7%. 99.7% they lies between plus minus 3 standard deviation. Is plus minus 3 standard deviation is like this. Minus 3 standard deviation from the central value average and plus 3 standard deviation from the mean, population mean. So if we move from the population mean plus 3 deviation and minus 3 deviation, how much total observation? It is 99.7. Remaining 0.3% observation. So like this. So you have to remember these are some standard values which you have to take care, and this will be used when we'll be solving the numericals on the normal distribution. These three data, plus minus 1 standard deviation, plus minus 2 standard deviation, plus minus 3 standard deviation gives you 68.2% of the total observation, 95.4% of the observation, 99.7% observations. Now, so what we have taken care, we have talked about binomial, which is a binary categorical variable. We talked about the expression, that is NCR p to the power r q to the power n minus r, where n and r were the n is the total number of observations. So that was binomial expression. There was a question which was related to the binomials. We covered that. Then we had certain assumptions related to normal and Poisson, that there has to be a discrete probability distribution. Poisson then came. They talked about Poisson, that is in a discrete probability distribution, where the formula for the probability distribution in the case of Poisson was given, where E was an average, lambda was an average value.